Hello, so in this chapter we're going to dig deeper into the C++ programming language. You can find an outline for this chapter on the course website, but in general we're going to look at the C++ syntax and how to write classes and when constructors get called, when default constructors get called. It can be a little bit confusing. And the order of those constructors being called is going to matter a lot when it comes to Arduino. We want to make sure that our setup code and assigning pins to certain functionality happens after Arduino has already been initialized, so we know that it's no longer going to change any of our configuration. After that, I'm going to show you how to use the Arduino command line interface, the Arduino CLI. I think you'll find that a lot more comfortable to use than the Arduino IDE. It does mean we can no longer just push the verify and upload buttons, but I think there's a lot to gain from using the command line interface. And as part of learning how to use the command line interface, I will also show you how to use a makefile to make the command line interface even easier to use on top of that. And I have an extension installed in Visual Studio Code that picks up makefiles and makes it so that you get a little bit of that functionality back for just being able to click upload or verify. That being said, I'm going to stop calling it upload and verify. I'm going to use the terminology that the command line interface uses. So instead of verify, they call it compile. And actually, I think they do use the word upload, but a lot of times you'll hear me call that flash too. That's just because I'm a little bit older and I'm used to having to flash the ROM. But without further ado, let's get started. I'll start by just opening the code for this course. And I'll make the font a little bit more friendly for recording. This is all code that you have access to. We have the old tweak code. You have the examples that I've provided and you can clone. And then there are also exercises, a couple of files that you've seen me write in videos, but that I didn't upload because I want you to write your own versions of display. And this over-the-air updates is something we'll come back to later in the semester. And then, of course, the library code. We're adding that into an include file folder. And you can see Visual Studio Code even picks up on the word include, and it's like, okay, that's a specially named folder. And so it uses a slightly different icon just to denote that. I'll start by creating just a new folder, because this is not really an Arduino example that I'm going to start with, and it's certainly not an Arduino exercise. It's just going to be some C++ syntax. So let's call this the CPP demo. And inside there I'm going to create a main C++ file. I'm essentially going to show you what Arduino is doing behind the scenes, sort of what is its value proposition, why do we even use it? Well, when you have your code inside of an INO folder, INO file, so I'll just add one of those here too, and we'll call that the sketch. Your sketch.ino has to include two functions. A setup function and a loop function. If you don't include those, you'll have some errors that the Arduino IDE or the command line interface will tell you you're missing the functionality you actually need to create something that can be uploaded to your board. But clearly this code is not enough for a valid C++ file. Or I should rather say a C++ executable. In fact, for that you need something called the main function. And at bare minimum they look like this in C++. I can actually make it void in C++. C is a little bit pickier on what I should have inside there. But that's essentially what Arduino is providing for you, is this main functionality. And inside there, it will call your setup function. And also inside there, it'll call your loop function inside of a infinite while loop. If I bring open the actual Arduino code, you'll see that this is more or less what it looks like. We've got main, the entry point. It calls setup. And then in an infinite loop, this is just another way to write an infinite loop in C++, it calls the loop function. What's missing here is a couple of extra calls. It'll initialize some Arduino code, it'll attach to the USB chip, and inside the loop after your code, it'll check for serial events. One possible serial event would be checking to see if the USB connection is providing a new sketch that should be overriding the current sketch. And so that's what happens inside a serial event run. It'll do this really nice and user-friendly check to see if the current sketch should be overwritten. That's something that makes Arduino much easier to use. It means you don't have to have a special programmer with special access to different pins on the device to overwrite the program, to flash a new program. But let's continue with our example of a fake Arduino setup here. There was that init function, so I might as well call that too. At this stage, we should have something that we can immediately just try to compile. So I'll open up my terminal, and I'll go into this CPP demo file, and I am not going to use the Arduino's compiler. I'm not going to use the compiler for our chip, rather. It's the Espressive Systems version of G++. Instead, I'm just going to use the built-in version of G++ on my laptop. If you're curious what that is, I can ask for the version, and you can see it's actually, behind the scenes, it's not G++. Apple has a version of Clang that they've forked, and it has special functionality just for Apple Silicon. If you want to know more about that, I can ask the command line where that is, and it's in user bin G++. And you can see it's just an executable sitting in user bin. So I can use G++ and I can pass it main.cpp, hit compile, and we'll see some error messages spit out. For C++, you're going to see a lot of error messages. They could really cascade and build on one another. If you miss a single semicolon, it'll give you sometimes pages of output. What I found to be the most useful technique is to scroll up to the topmost and read that error first. So it's telling me that it actually does want the return type to be int. I think what I was remembering is that if you don't have a return, it doesn't give you a warning on that. Instead, it just manually adds a return 0 at the end. So we'll remove that because we're not returning anything special from here. There's no significant meaning for it, so I might as well remove that code. But yes, I do have to have the correct return type. We can try to compile again. And now it's saying unused or undeclared identifier init, undeclared identifier setup, undeclared identifier loop. So what does Arduino do in this case? Well, there's a number of different ways we could handle this. The way Arduino uses is basically stitches these files together, the sketch.ino and the main CPP file. One way we can do that is by just manually including that file. So that will get rid of the two errors denoting that setup and loop were missing, because now they've just been copied and pasted into the top of this file. This is not quite how Arduino does it. It does it using a different type of pre-processing setup step, but for all intents and purposes, it's really just copying and pasting it above the main loop. And how about this init function? That still needs to be identified. Well, for Arduino, they will include a file called arduino.h. And I am going to change this to fake arduino.h, just so I can control that and put it in the current directory. So I will create that file. And now my error message goes away. I'm still going to have the same error though, because I haven't actually defined the init function. And just to prove that, we'll recompile and realize there's nothing to compile here. There's no code associated with the init function. So let's write that inside here. And this will actually do some important setup. And if I jump over to the simple AVR version of Arduino.h, we should find in here some things that you might recognize. The fact that high and low have been defined, input and output have been defined, some useful constants, values for serial and display, And I would guess somewhere in here, so they've also have macros defined for simple functions. Somewhere in here we should find an init function. And it looks like the way Arduino defines that is those are actually going to be defined in other files. I'm not going to go through another step of indirection, but my guess is the reason that those are defined elsewhere is because they depend on the exact board that you're using. Are you using an Arduino Uno or an Arduino Mega? The init functionality will be different depending on the microcontroller you're setting up. So for our ESP32, it'll be different than an ESP32, we're using an ESP32S3, it'll be different than an S2 or a C3 or a C6. All those different microcontrollers will have different initialization files, so that would be another one that's just pasted together depending on certain configurations. And we'll go a little bit into how that all was discovered when we start playing around with the Arduino CLI in a bit. But let's jump back to our code. Now that I've defined init, I should be able to compile this. And what we're left with as an output is an executable that can run. And by default, when I call G++, it'll compile a binary that can run on my local machine. So I can run that file. And it gets stuck into that infinite loop that we had in our main function here. It's just happily calling loop, which happily does nothing. So this version doesn't really do anything, it just gets us stuck in a loop that never ends. And that's exactly what we want on a microcontroller. If the program ends, it's not really well defined what that should actually mean. So almost all of your programs for an embedded system, like we have for our robots, will have a program that never ends. You're just putting a single process or a single executable on the device. You're not going to have Spotify running and a web browser running and Visual Studio Code running. Really, you'll just have that one binary, and it executes until you turn the microcontroller off. And so what that looks like would be killing the program that turns it off, and the second that you restart or repower the device, it just calls that program again, just starts it again, jumps into the same main function again. And that's all handled by the 2 levels of bootloader that we discussed a couple of chapters ago. The last thing that I want to demonstrate here is just the importance of main. That's called the entry point. So if I were to turn this into a differently named function, C++ is now going to argue with me that I have something that's a valid program. It'll say undefined symbols. Your compiler, when it's getting to the linking stage, is always going to expect for that main function to exist somewhere. And if it gets through compiling your program and linking it with other libraries and binary files, if it gets through that entire process and main hasn't been defined anywhere, then your program does not know where to start. If you were creating a library, that wouldn't be that much of a problem. We could just create, compile something that doesn't need main. And if I remember correctly, I think if I do the -c flag, yeah, it'll compile this file and just say, hey, it's okay that there's no main file, you're not going to execute this. And it'll create this main.o, this object file that can then be linked with something else later on. But I don't have something I can execute. I cannot do /main.o and run that. It says it exists, but it's not an executable file. That's actually a message from my shell. But even if I were to turn it into an executable, so currently read permission, write permission, but no execute permission, even if I were to add execute permission, now I would get a different problem. This is an error from the operating system saying could not be run by the operating system because it doesn't have an entry point. There's no main function defined. So even though when we look at your sketch file, something like this sketch.ino, even though there's no main defined here, it is defined elsewhere, and it's running code before your code. And so that's where I'll stop this video, but in the next one, we'll explore a little bit about what code is actually executed before your code. I'm looking at it mostly from a C++ viewpoint, not necessarily just an Arduino standpoint.